think that's it. Okay, let's talk about kites. I bet you didn't know that kites really are the name of the shape. It's not just a fun thing to fly in the wind. Speaking of tornadoes. This is, what are we in, 5-5? So I'll say 5-5 continued. Kites. So if you draw what you think a kite looks like, you're probably going to draw it accurately. I would think, because most of you are going to draw something kind of along the lines of this, I would guess. You could even pretend, give yourself a little string here. Some bows on it if you want. Be fancy and throw a key on it like who did? Yes, our old friend Benny. So any Hoosers, what makes a kite a kite? Here's what you have to have. You have to have two consecutive sides that are congruent to each other. So these two are going to be the same. And then you're going to have another pair here. So those are the same. Okay, so that is what makes a kite a kite. It is not a parallelogram. Okay, not a parallelogram. It does not have all those fun facts about parallelograms. All right, so kite, it is a quadrilateral because it's a four-sided figure. So quadrilateral with two pairs of congruent consecutive sides. So I'm even going to add not a parallelogram. That's important to distinguish. All right, now the kite does have a few of its own fun facts. What appears to be true about the diagonals in a kite? Carson? In my picture, yes, I could see how you would say that, but that unfortunately won't always be true. There is something that will always be true for every kite. And the Patrick, they are perpendicular, which makes sense, right? Haven't you ever gotten those kites where you put the stick in, right? And you put the two sticks and it makes a perfect 90-degree angle there. And that's how you fly your kite around, right? So those diagonals are going to be perpendicular in a kite. That is always true. Okay, so fun fact for a kite. Diagonals, oops, let's spell diagonals right. Diagonals are perpendicular. Do they bisect each other? Bisect each other? No, that would be impossible because the only things that bisect, that have diagonals that bisect each other, are parallelograms, and this is not that. However, take a look at what's going on here. I'm going to zoom in a little bit on my kite that I drew. Or maybe I'll draw another one. Nice big kite down here. Oops, no. All right, so let me mark some things here. So if it's a kite, I know I'm going to have these sides the same, these sides the same. I'm going to go ahead and draw in those diagonals. Let me also ask you, does it appear as if the diagonals are equal in length? No, I have. That one was super long and this one is much shorter. So, okay, they are going to be perpendicular. So all of these would end up being 90s. All right, so what I'd like to talk about for a moment is the two top triangles here. So I'll call them triangles 1 and 2. Could you prove to me that those two triangles are congruent to each other, given just what's marked here?
Yes.
Yeah. How? Patrick? Yes, they share the side down the middle. Okay, so if I wanted to, I could add that marking in. Hypotenuse leg, they share it. So what that means is if those two triangles are the same, couldn't I use CPCTC all over the place and say this angle right here is the same as this angle right here? Right? Couldn't I also say, okay, well, you are still using CPCTC, wouldn't that angle and this angle have to match up? Yeah, so those two top triangles are completely the same as each other. It's just one's here and then I flop it over. Let's talk about triangles 3 and 4. Would you say that those two triangles are the same?
Yes.
Sure, same reason, right? Hypotenuse leg, so I get all those same things. Now be careful. Oh, I could, right? Because you had, yeah. So I've got lots of options. Triangles 3 and 4 are definitely congruent. Now, here's a good question for you. This angle right here, let's call this angle, I'll stick a 5 in there because I already used 1, 2, 3, 4. Is angle 5, that one that I just marked right there, would that be congruent to angle 6 down here? No, we have no way to show that. All I know is that 6 and 7, those two would be equal to each other by CPCTC, right? So if I want to go ahead and mark it, I don't want to mark it with 1 arc or 2 arcs because I've already used that. So yeah, I guess I'm going to have to use 3 arcs. That's annoying, but it is what it is. So those two would be the same. Let me put some numbers in here. What about angles 8 and 9? What's the deal with them, if anything? Are those the same as, I'll call this 10 and 11 up here? Are 8 and 9 the same as 10 and 11? These two triangles are the same, so their parts match up. They don't necessarily match up with the ones up there. Are triangles 1 and 3 the same? No, you cannot prove to me that 1 and 3 are the same. All you have is that they're both right triangles, but as we know, not all right triangles are congruent to each other, are they? No. So keep that in mind. Your top two triangles same as each other. Bottom two triangles same as each other. So down here, I'm going to switch. I'll change color and I'll use a slash because I'm not doing 4 arcs. I'll do that. So if I were to ask you this question, do the diagonals in a kite bisect the angles of the kite? What would you say? Let me rephrase so I'm super clear. Do both diagonals of a kite bisect the angles of the kite? Oh, no. Remember in a rhombus that happened? In a rhombus, if you draw in both diagonals bisect the angles of the rhombus. Remember that? In a kite, one diagonal does and one doesn't. Do you see that? This long diagonal vertically, that is bisecting the top angle and the bottom angle. So that one diagonal is bisecting both of its angles of the kite, but the other diagonal is not. These two angles here are not the same as each other. So that's important to note, right? If I say diagonals, plural, of a kite bisect the angles of the kite, that's not true. But if I said a diagonal of a kite bisects the angles of a kite, that's true, because one of them does. Do kites have any other fun facts? Not full ones, like it is true that the diagonals are always perpendicular, but then you get all of these half things. You get these two triangles congruent, these two triangles congruent. Oh, are the diagonals, is there a diagonal that gets bisected? One diagonal gets bisected, but not the other. So we can add, sometimes we call them half facts. Let's switch back to blue. Half facts. So one diagonal bisects the angles of the kite. One diagonal bisects the other. And I guess you can throw on there that you'll always get those, you'll get two pairs of congruent triangles, but not, you'll never get all four congruent to each other. So if you draw in those two diagonals, you will get two pairs of congruent triangles. Interesting, interesting, interesting. Questions? Anybody have a question? No? All right, so what I want to do, I'm going to look at your quiz and just make sure that anything I possibly needed to talk to you about, I did. So I'm just gonna run down what it's gonna look like. Oh yeah, we should do some of those. Those are always so fun. So first you have some sometimes always never. So for example, I could say something like a rectangle is a square. Sometimes always or never. Sometimes if that rectangle just so happens to be drawn with 4 equal sides. A square is a rectangle. Always. That's always true. Because a square always fits the definition of a rectangle. It always has 4 90-degree angles. A square is a rhombus. Always. A rhombus is a rectangle. Sometimes. If that rhombus happens to have 90-degree angles, then wouldn't it be a rectangle? So it can happen. So you'd say sometimes. A trapezoid is a square. Never. That can never, ever, ever be true. A kite is a trapezoid. Ooh, I'm actually not even sure if I know that. I think it's never. Because you'd have to have, yeah, how could you have the one pair of parallel sides? Is there a way with, no, not with. I don't think a trapezoid could be a kite. Yeah, I think they're, those are separate. I don't think we can have any overlaps with parallelogram, kites and trapezoids. Okay. The next section, we're gonna practice, let me just give you some random ones. Name for me all of the sides out of the ones that we talked about. So I'll just put their letters. So you could have a quadrilateral, a parallelogram, a rectangle, a rhombus, a square, a trapezoid, an isosceles trapezoid, and a kite. I think that's everybody. All right, so out of those, who has, we'll start off easy, 4 sides. All of them, right? All of them have 4 sides. Who has 2 pairs of parallel sides? Go down the list. Does a quadrilateral always have that? No. Does a parallelogram have that? Yes. Does a rectangle always have 2 pairs of parallel sides? Yes. Rhombus? Yes. Yes. Square? Yes. Trapezoid? No. Isosceles trapezoid? Kite? No. Who has all of their sides the same? Square? Rhombus? Anybody else? That's it. The square and the rhombus are the only 2 in this list that always have all 4 sides the same. Who has perpendicular diagonals? Kite. We just learned that one. So we got kite.
Rhombus.
A rhombus. Any more? Oh, I heard it. Square. Squares. A square is a rhombus. So if you say something is true about a rhombus, it's automatically true about a square. If you say something is true about a rectangle, it's automatically true about a square. If you say something is true about a parallelogram, it's true for all the parallelograms that come after it, which are rectangle, rhombus, and square. Oh, fun. Okay, I'll do one more, and then I'll do some drawings for you. Let's see, who has consecutive angles congruent? Squares do. Consecutive angles congruent. So square, a rectangle. Does anybody else? You mean trapezoid? So you'd have to clarify. So I said, what did I say? Consecutive angles congruent. So an isosceles trapezoid has 2 pairs of consecutive angles that are supplementary, but not all of them. Think about it. The only way to get all of your consecutive angles to be congruent, what would the measure of them have to be? Wouldn't they have to be 90s? So you're basically asking who has 90-degree angles. So it's got to be our square rectangle. Okay, gosh, if only we had our chart filled out in front of us, we could have answered those so quickly, right? Right? Not saying that you had to have it, but how handy that chart could be. Just saying. Okay, let's try this. I'm going to draw for you a picture, and you tell me, I'll leave these up because you might still need them. You tell me what shapes are reflected in my drawing, okay? So remember, nothing is drawn to scale. You have to go off of my markings. So if I do this, and I do this, I draw in my diagonals, and I show that they are perpendicular. Who in this list could this be? Nothing's drawn to scale. Who could it be? Who always has this? Square. Keep going. Do rectangles always have perpendicular diagonals? Rhombus. Kite. Who's this? Or who could this be? Rectangle. Well, I heard square. You almost always have that. You want who always has this characteristic. I think that might be it. That's it. Try one more maybe. So I heard kite. Kite would only have one of them would be bisected, not the other. So it can't have kite, but I did hear, I had something else. Rhombus would work. Ask yourself what's going on in this picture. Like in the first one, there the diagonals were perpendicular, right? So now you're really asking, okay, who has perpendicular diagonals? What's happening in this one? I have diagonals that are bisected. Are both diagonals bisected? What? Yes. Parallelograms have diagonals that bisect each other. So if it's true for a parallelogram, who else is it true for? Square? Rectangle. Yeah, it's true for every parallelogram. Rectangle. I think we got them all now. If it's true for a parallelogram, it's true for all of the types of parallelograms. Rectangle, rhombus, square. Okay, we'll do one more. What if I told you this whole diagonal, so AB, is equal to this whole diagonal CD? So AB is congruent to CD. Who has that? Rectangles do. Square. Anybody else? Yes. The isosceles trapezoid had that too. Notice my diagonals are not getting bisected here. It just says that they're congruent to each other. In the isosceles trapezoid, the two diagonals are congruent. So isosceles trapezoid. I think that might be it. Equal diagonals. Yes. That's it. Okay. So that's stuff on the front. On the back, I'm going to give you, gosh. I'm going to give you things like, I don't know. Maybe I'll do something like this. I'll tell you, hey, this thing here is a parallelogram, ABCD. And then I might say something like, okay, well, if this is 2x plus 5, and this is, I don't know. Maybe I'll tell you this is 15, and this is whatever, 20. I might say, okay, solve for x. Could you? Maybe I'll do one with the angles too. What if I said this was 8x, and this were 12x minus 20. Oh, I can't use the same variable. What am I thinking? Let's make these y's. Sorry, made it worse. There we go. So take a moment, solve for x and y. So I could give you something along those lines. Okay, we got answers? All right. Sam, go ahead.
For y, I said -50.
Negative 50. You sure?
Because 8y plus root 20 would say 20.
It's supposed to.
Yeah.
Well, let's do it together. So your equation's right. 8y plus 12y minus 20 is supposed to equal 180. Right? 8y plus 12y is 20y. Let's add that 20 to the other side, so that would give me 200.
I accidentally subtracted the 8 from the 12.
Oh. But your equation was spot on. So did everybody get that same equation that you're going to add your angles together so it equals 180? I hope. Okay, good. So then y ends up being 10. And then x ends up being, everybody have a value for x? Go ahead, Sam.
I got 12.5.
What is your equation?
Isn't that 20? 2x plus 5 equals 20.
Yes. Your equations are great, but I don't know what you're doing. What should I do?
Subtracted 5.
Yes.
That's 15.
That is.
Yeah, 15 divided by 12.
25 divided by 2 is 12.5, not 15.
Oh, whoops. That's my bad again.
So, but yes, that is my correct answer. This 15 that I gave you over here was just to throw you off. You don't do anything with that one because it's opposite sides that are equal, not that one. Okay. So if I gave you some questions like that, I'm sure you could, right? If I gave you a rhombus and I gave you some information about the sides, you know that they're all equal. So you could write any equation that you needed to by just setting them equal to each other. If I gave you whatever, anything, a parallelogram and the diagonals, you know that the diagonals bisect each other, so you could set those two sides of a diagonal equal. So anyway, that's the whole quiz. So does that seem so bad? No. All right, so I want to play a game. I just sort of made this game up. So let's see how this goes. I'm going to stop this video here. Oh my gosh, I can't wait. Oh boy. Okay, now let me stop the video. There it is.